This is an interview with the founders of AutoGen, Dr. Ji Wang and Dr. Xingyun Wu. Dr. Wang is a senior staff researcher at Google DeepMind, and Dr. Wu is an assistant professor at Penn State University. Both of them are responsible for the creation of the original AutoGen and now AG2. So we're going to talk about everything from agents to open source to so much more. So let's get into it. So I would love to hear about the origin story of AutoGen. I know, as you've told me, it's a collaboration between Penn State and Microsoft, but how did that come to be? What were you both working on prior to that? And then how did you meet each other? How did you start that project?
Yeah, thank you, Matthew, for asking that. Yes, indeed, when AutoGen was created, I'm at Penn State University and Chi is at Microsoft Research. And before that, we were both working on another project, open source project called Flamo. It is a library for automated machine learning and hyperparameter tuning. And me and Chi has been working on that project for over, like up to today, is over five,
Yeah.
6 years. Yeah, we started that project 2019. And when I was interning at Microsoft Research with Chi, and my intern project was about hyperparameter tuning, and we invented a very efficient hyperparameter optimization algorithm. And we decided that we should make it that open source and benefit the others. And then we released this Flamo library, and since then has been working on this open source project starting from 2019, and we have been also building a community around Flamo. And actually, I'm not trying to advertise Flamo here, but Flamo has been adopted by many enterprise users, especially in the fintech in the fintech industry. Like many banks, they have this tabular data, and they have this like they find this AutoML library very efficient, and there are a lot of adoption. We have, like, I think, millions of downloads of the Flamo from library. So we have been working on this Flamo project, and then we see the huge potential of generative models, and we have been thinking about how we empower people using large language models and those generative and foundation models. And perhaps she can tell a little bit more about that, how we reached this idea.
Yeah, sure. As Jimmy mentioned, we're both working on the Flamo, using AutoML techniques to help data scientists and machine learning engineers to choose the best model for their applications. And when GPT-3 is out, it's a very new kind of models that with new capabilities. So a natural idea for us is to try the AutoML technique to try to tune the inference parameters of the GPT models and see how much it matters. It turned out it mattered a lot. So for several problems like math problem solving, coding, and other text generation tasks, we found choosing the best inference parameters can make the model perform well and also minimize their inference cost. Then that's the time we realized there was a big opportunity about how to best use these models and make them maximize their utility for different applications. It's not simply just putting the model, do the inference once and get the job done. There often involves multiple inferences, multiple other steps that are not about using the models, but other steps like using tools or getting human inputs and so on. So it's a big design space. Based on our experience of AutoML, natural ideas, can we help developers to easily navigate that large design space quickly and provide the optimal solution? But before we can do that, we first need to have a solid fundamental framework. Just like in the machine learning area, we had some standard machine learning framework like scikit-learn, PyTorch, Hugging Face, and so on. Those provide a simple interface to easily navigate the large design space. And then on top of that, we can apply some automated machine learning techniques, optimization techniques to automate that process of optimization. But at the time for the language models, there was no At the time we started building AutoGen, there was no good unified framework yet. So we decided to build one first ourselves. So that's the motivation of starting building AutoGen.
And when did you first see the potential of agents collaborating with each other? Because when I first saw AutoGen, it was one of the first times I had even thought that, hey, if you allow one agent to communicate with the other, they can correct each other's work. They can iterate on an output before giving you the final output. So it was somewhat new to me. When was the first time that you had that aha moment and saw the potential of agents working together?
Yeah, Jun, shall I answer or do you want to go first?
Yeah, I can briefly talk about my aha moment. So
Yeah.
we at that time we were trying to solve some math problem, and we choose math problem is because first it is important, and also it is very challenging, and another reason is easier to evaluate, and also another third reason is I like math. I like math, and I'm also an educator. I'm a professor, and I care about education. And I was thinking about some application related to tutoring, math tutoring. And so when we try to solve very challenging math problem, and we find that typically we may want to involve tools to using, and also sometimes to write some code to do some calculation. And when it involves code, and we find that this we need to do this iterative coding, code generation and debugging, code execution, and this back and forth debugging. And we found really if it will be very handy if we can have an executor agent that can execute the code. And on the other hand, another reason is we may want to involve human in the loop. For example, we may want to involve the extra the human tutor and to help with the student when the model cannot help. So combining these two, we come up with this user proxy agent idea. And the original motivation of that is to mimic what a human would do when interacting with, for example, ChatGPT. At that time, ChatGPT can only potentially generate code, but it cannot execute code. And then if you interact with ChatGPT, the human user will need to copy the code and then run the code and get the result back,
Right.
and then continue the conversation. So it's basically mimicking what an end user would do. So that essentially forms a two-agent chat. One is the assistant agent backed by a large language model, and another user proxy agent trying to mimic what a human would do. So that's one aha moment for me. This whole process is fully autonomous. You can see these two agents are autonomously back and forth debugging and chatting with each other to solve the task. It's really fascinating.
And for me, the starting point is really ChatGPT. I think ChatGPT is a big step forward compared to the previous GPT-3 models just doing text generation. But ChatGPT is really the time that it's got the significant impact by just the general public. And I think the reason for that is this chat interface has allowed natural participants of human to provide feedback when something goes wrong. They can back and forth iterate over that. And when I think about that, I immediately relate this to some of my personal experience in college. When I took a seminar in quantum computing and quantum communication, my professor Renyao Duan, he gave me a lesson. He told me that conversation or dialogue is a proven way to make progress in creating new knowledge, proving the new knowledge, and generating new learnings. And that has deep theoretical ground in that process. And when I think about why ChatGPT has a huge success, I think it's a very good demonstration of that theory, but in a like very new technology. Now we have the models that are very capable of doing the conversation, not just human. that has a huge implication. Now, if ChatGPT starts as communication between AI and human, but if you think about there's no reason to prevent us to use the AI models to also converse with each other. Of course, human can still be involved in the conversation, but not necessarily just one human versus one AI model. And later we see GPT-4, it's even pushing that capability to a higher level, and the the models demonstrate many more capabilities, including reasoning, very strong reasoning, planning, and debugging, and so on. And each of these capabilities can be configured for different agents to play different roles, and even the whole process of like generating code, doing testing, doing like review, and then revert back. There's a whole loop of workflow process. If we think about enlarging the scope of the way we're using the language models at that time, but try to include more steps or more processes in the loop, and having the models to automate as much as we can, then the level of complexity of the tasks we can achieve will be much higher. I was thinking about several concrete applications. Some of them are like data generations, but usually we need to kind of have one agent to address the request from a user, and the user need to provide input. But if we replace the user with AI agent, then possibly we can automate that data generation process and generate a lot of different kind of training data corresponding to different personality or background, and collect a large amount of useful data. That's just one example application. And before I jump into the application, I thought this can have a huge implication. If you generalize this pattern, it has a big implication and big opportunities to model much more complicated processes like that one. And as Chun mentioned, we took the math problem solving as one initial case study. And after we have a very deep understanding of that, and after we make the two agents working with each other work. By the way, the two agent is one assistant agent simulating the ChatGPT backed by GPT models, and another user proxy agent that simulates humans' behavior, including including executed code suggested by the AI agent. And there are different modes from the user proxy, including automatic execution or manual feedback. And after making that two-agent conversation paradigm working really well, we also took some feedback from initial users, and found that there are also a need to generalize this conversation pattern to accommodate more agents, more different roles, and also different communication patterns. So we could quickly evolve from a simple two-agent communication to more agents, and that's where like the magic started.
So I'm going to ask you a little bit about some of the best practices that you've discovered over time, but I want to save that for a little bit later. Once you started working on the original AutoGen, how long were you building until you first published publicly?
Yeah, that's a good question. The thinking started much earlier. Thinking started around the time of late 2022, when at the same time when we kind of tried the AutoML for tuning the parameters for the models. And at that moment, we started to think, okay, what's the right abstraction to accommodate this very large design space that includes models, tools, and humans, and all the different types of entities together? What's the most intuitive way for developers to reason in that space? So that took quite several months to figure out the right way to do it. So around the time when GPT-4 was released, that's April in 2023. That's real kind of starting point to use agents as the abstraction to start building the agent framework. And from then to August is basically the time we heavily working on like building the agent framework, get initial feedback from users, and iterate. I think in August we wrote the first research paper. Jun, do you have
And
anything to add?
Yeah.
oh,
Yeah.
please.
Yeah, that's about the timeline. Like several months to build the initial version of AutoGen, and also provide some case study, application study, and put that study into that paper. Like in total, actually, it's not that long. It's just several months, 4 months.
Yeah.
And so
One thing I want to, sorry.
no, please.
In terms of being public, it's actually public since the beginning. So since April, when we wrote our first line of code, it's written in the open source Flammo project. So every single line is written in
Yeah.
public. But it's just that we didn't write down anything. So
And the
like,
report, yeah.
any report, right? So people, most people didn't find it, but the Flammo community has some awareness.
Yeah, they have the early access to AutoGen, our
But so
smaller Flammo community.
when the more mainstream, like myself, first got eyes on this, what was I mean, I know what my reaction was, and kind of the folks who I was speaking with about it, but what was the feeling for you both, like when you put it out there? And I assume people were just stunned by it because it was just so interesting and so different than anything I had seen before. What was that feeling like in those first couple of weeks after publishing? Or I know you published prior, but really like getting it out there.
For myself, I to be honest, I never imagined this happen. So I am just working on my idea and working on our idea, and want to kind of make it useful. And I didn't imagine like this can be so popular. And I was very shocked and also of course in a good way. And I'm very motivated to make it much better. That's my reaction.
Yeah, let me tell you some story, Matthew. I set a goal. I set a 1 year goal for the AutoGen project when I spin it off from Flammo. I set a specific number of like stars on GitHub for AutoGen for
I
1
knew you
year.
were going to say a certain
Can you
number of
guess?
stars. Yeah. Let me guess.
Yeah.
1,000 stars.
Yeah, exactly.
Oh yeah.
Exactly, because you're so right. Because based on our Flammo's experience, we were growing the community steadily, but also incrementally, right? So we talked to every single user of Flammo since the beginning, and we do a lot of iterations at each time. So it's been also like a very manageable path of community growth, but AutoGen is totally different. So just within a few days after release, I realized I need to change my goal.
That's so cool.
I changed my 1 year goal after several days.
That's
so
amazing.
really,
yeah, and I just looked, and it is currently at over 35,000 stars. So no big deal. No big deal. That's amazing. I want to talk to you both a little bit about open source. Obviously, maybe not obviously, but in academia and especially like Microsoft research, open source is a big part of it. But I don't think, at least in the enterprise side of things, people have adopted open source like they have in the AI community. And I'm really excited about that. And this is something I've been thinking a lot about lately. I personally, prior to kind of really diving headfirst into artificial intelligence, was not very knowledgeable about open source and the value that open source brings. So talk to me a little bit about your journey to open source. Have you always been into open? Was it just not a question? Like, obviously we're going to be publishing, so we need to publish the code as well. Like, what Was it a decision to make AutoGen open source, or was that just the default?
Yeah, I can share my like journey in the open source world. It's it's not a smooth one since the beginning. It's kind of more like a very how to say, incidental, or well, it's a coincidence actually for me to get into that world. For the initial multiple years of my work at Microsoft Research, I was mainly just working on techniques, writing research papers, and also occasionally talk to product teams to ask them to use it, but never did any open source work. That the first time we did that is for the Flammo project, and it's I think I was very lucky to make that call. But it's not also not open source since the beginning. So at the first time, we also followed our previous playbook. We just we did some a theoretical study. We proved some theories, and then we wrote a research paper about it. At that time, I think not many people know about that Flammo work, that AutoML work. Until I think someday, like one user reached out, say they found a paper, they really want to try it out, and they want us to share the code. But we didn't have like a ready to share code at that time. We have some research prototype, but we try to offer a license, like a private license, not open source, to that initial user. Although they preferred open source. So that's the first try, and because that time the code is more like research prototype quality, it's not ready to be adopted right away. And then after some time, like another user reached out again after reading the paper, and again they asked whether we have open source offering. So that's the time I thought, okay, we couldn't wait anymore, any longer. We should do the open source as soon as possible. Otherwise, this is the same pattern we may repeat and so on. And because we didn't have experience at that time, like you mentioned, we were not sure whether it's a good idea, how much it will make, and would this really make a large scale of adoption? We don't have the answer, but at least for this this one user and maybe the previous users, they have this requirement, they have this need. We don't have any better alternative, though, so let's just do it. But that opens the door of this new world, and since then we have learned so much, right, in that journey. So it's like every time we address some users' concerns, we make the library much better in terms of usability, and it also drives a lot of the follow-up research work in multiple years following that. So the library got better and better, and the adoption increased from maybe small to medium-sized companies to large-scale companies, including some big products in Microsoft and other companies. And so by the time we started building AutoGen, I think that lesson was already very clear to us, and the timing, but both the decision about doing open source and also the timing to do it, I think are driven by our previous lessons from building Flammo. So you can see that this time we took a very different approach when building AutoGen. We wrote the code, everything since beginning is open source, so that ensures the fastest speed to get initial user feedback and for fast iterations, and that doesn't slow down, like, I think, the adoption from enterprise companies, but I rather accelerate that. We have learned huge amount of like enterprise use cases and adoptions after the like you said, after it's got awareness in the open public. And yeah, so this is a big learning for me, at least personally. Qing, what do you think? What's your
Yeah, I'd also love to share my journey. So roughly there are several stages, like about 3 stages. So I used to be like a PhD student, and when I'm doing my PhD, the default mode is to share code, to share my research, make my research available, accessible to the others for many reasons, like reproducibility and making an impact. And that's kind of the default mode. And I didn't think too much about it. It's just a default, probably because of my PhD advisor. He has kind of this high standard. And we want to make our research high standard and reproducible, and let the others like audit our research. So that's kind of the naive default period. And then we will work on the Flammo project. And we actually see some enterprise adoption, and like much more usage from the user comparing to my PhD research. And we have millions of downloads. And at that stage is more on the personal level. I see, okay, my research is making an impact. I see like the impact it makes. People are using this in their real world use cases, and it just personally feel very fulfilling to as a researcher. And that's kind of a personal impact stage. And at the AutoGen stage, we have like much wider adoption and visibility. And at that stage, of course, I very appreciate like the passion and the interest from the users to AutoGen, and that allows me to kind of stand on a higher level, and have been actually thinking about for contributors, for users, what does it mean to have this open source library, and what can benefit the contributors and benefit the users. And I think the open source is really a very healthy ecosystem. For the contributors, they can make their research, make their contribution accessible to the others, and can also build based on the others' contribution, and make it available to the world to use. And on the user level, especially for you asked about enterprise users, I think one important thing that open source software brings is transparency and trust, because all the code is available and everyone can look at it. And so there is a natural transparency there, and also there is a kind of sharing spirit, like if there is something good, we should share it to the world to benefit the whole world. And that's another benefit. And another kind of benefit to the enterprise is open source can grow very large, and can grow a whole community and ecosystem, and make it easy for their employee kind of to use it. For example, if there are a lot of people are already using the software infrastructure, and when they onboard new employee, and it's easy to let them to use this software and start building, instead of learning some software that is only specific to their internal team. And I think this is a very healthy ecosystem.
Yeah. And I really first of all, appreciate you both for contributing to open source. And I also think it feels like there's something special about the AI industry, where maybe because it is so raw right now, or maybe because so many people who are trying to build things also come from research and academia, that open source feels like the default, which is really nice.
Yeah.
And obviously you both were big contributors on that momentum, and it feels really cool. And it's not something that I'm used to. And so I really like being able to go and look at the code and download it and play with it on my own computer, and tinker with it and change things that I don't like, or enhance things that I do, and potentially submit those enhancements for other people to benefit from. So I really like that. And on that, I want to talk a little bit, obviously, about agents, and like let's talk about some practical matters for the folks listening. And a lot of the people who watch my channel are builders. So they're tinkerers, they're builders, they're at companies, they're building their own projects on the side, and they want to use agents. What are some of the best practices that you've seen from AutoGen and agents in general that people should think about, whether that's the types of models to use, the number of agents, how verbose the prompt or the system messages should be? What are some of those very practical, very tangible best practices that two agent experts would give to the audience?
Yeah. Shall I start, or do you want to start first? Yeah.
Yeah, I can give some of my 2 cents, and which probably is not. I'm not sure whether this is so unique, but I really feel starting with prototyping and having one single instance of the task work is really a very good starting point, and it's also a very rewarding experience, and it allows you to experiment with different approaches, and I think that's a good, generally a very good starting point, at least based on my experience.
Yeah, the best practice definitely evolves over time. In the beginning, when we have the initial version of AutoGen, we have some guidelines in the technical report we wrote. It says begin with a simple setup of maybe 2 agents, just one assistant agent that you can put all the instructions about the things you want the AI to do in that one agent, and make another agent called user proxy agent and give it the right capability like a code execution, depending on whether you need that, and start experimenting with that setup. So when the task is simple enough, that's 2 agent setup can work quite well already. And when the task is complex, then usually we see the single model-based agent cannot follow all the instructions nicely, to forget instructions or not doing certain steps in a very high-quality way. And that's a time maybe you need to think about breaking down the task into smaller pieces and have specialized agents focusing on the simpler tasks, so that for each step they can finish with higher quality. And when you do that, you also likely need to think about the topology of the communication among these multiple agents, because it's simple for the 2 agents. It's just taking turns. I say something, you say something, I say something. But for once you have more than 2, then the number of choices becomes very large, and actually infinite. There can be infinite number of choices. If you just think about the 3 of us speaking, the order of this can be infinite. Like you can say ABC, that's one type of pattern, or you can do A B A B A B C A B A B C, right? Or A B C A B A B C. Okay, so there's just endless number of enumerations. So there needs to be a intuitive, a natural way for the multiple agents working together, and we provide a few basic conversation patterns or building blocks, including sequential chats, nested chats, and group chat. And depending on how much control you want in the workflow, you can choose or mix them for different purposes, different subparts in your workflow. There are patterns that are with more flexibility, and there are patterns with more controllability, and there are also patterns that can help you isolate the work, the inner work from one agent to other work, like the nested chat. So that's maybe the second stage. And regarding like the models or tools used, now when you have multiple agents, you do have more freedom of choosing different models, giving them different configurations, or providing different tools for each of them to make the best out of it. So it actually makes you easier to optimize for multiple metrics as you want. Sometimes you want to usually you want to maximize the quality, but in some cases you also want to bring down the cost or latency, and you can do that with multi-agent setup. So that's some like medium some other guidelines maybe after evolution, and I also have some even more recent suggestion or guidelines that's corresponding to the recent new features in AG2. And these practices are related to the two important features in the new version of AG2. One of them is called Captain Agent, another is called Swarm Agent. They represent two different practices. Both are needed in most cases. The Captain Agent represents a paradigm of fully automatic way of creating agent and agent teams tailored to a specific task. The users just need to provide a task to the Captain Agent, and the Captain Agent will analyze the task, decompose it, and then create different agent teams on the fly for each step in the process. So the entire process can be automated. The users just need to provide input the task, and all the intermediate steps are automated. And users can also look at what agents are created or selected from existing library. They can both utilize existing agents or tools or create new ones on demand. So that's one paradigm. And again, for relatively simple tasks, that can work well. And when the task is too complicated, or when we don't have enough tools or agents already provided, it may fail to generate the right tools. And that time, but often it will give you something already, give us part of the solutions. And then the developers can maybe look at what are suggested and take whatever useful as a starting point, but add some missing pieces. It can be some missing tools to add, or some missing agents of particular roles that only the domain experts know, but currently the Captain Agent doesn't know, right? So then the developers can use the created or suggested agents and combine that with the Swarm pattern. A Swarm is like a high-level program interface that's similar to OpenAI's Swarm framework, but combined with all the rich functionalities within AG2, so that all the conversation patterns can still be programmed using the Swarm pattern, but more intuitively and simpler in a simpler way. So now you can take the suggested agents from the Captain Agent and make them work together using Swarm pattern and define the necessary kind of transitions or instructions about how to hand off to different agents. Also, they can share some context variables. They can share information in a more structured way and leveraging the new structured output features from AG2. So there are these two different kind of very useful ways, and you can combine them together in your development process. So that's the latest kind of suggestion or guideline. I think that can be used as a best practice. But over time, we probably will also discover more and share more.
Yeah. Actually, another kind of general guideline, very general guideline I find useful is to think about how human organization solve the problem, because I think it's reasonable to treat a language model as a human with probably medium intelligence, and we have already the society has already developed ways to approach different problems. For example, for handling HR, and typically in a company you may have an HR team, and there are probably different smaller roles for handling HR. I think mimicking what human organization would do is a generally good starting point.
So as a quick follow-up, we talked a little bit about best practices, and one of the best practices that I frequently get asked about is human in the loop. When is the right time for the human to be in the loop? What have you seen in terms of your own projects or other kind of more complex enterprise level projects, what is the right time for the human to be in the loop? Is there kind of a standard definition of certain complexity or a certain importance of a decision? How do you define when that human should be involved?
Yeah, I have some initial thoughts. I can take the first, and Chun, you can add that to that.
Mm-hmm.
I think the depending on the technology advancement, the kind of the type of involvement from human can vary. But I think if we think just very far ahead, if we think what's the end game, let's say the agents can have capability-wise, they're so strong so that they can finish pretty much all the tasks we want them to finish. By that time, what do we still need from human? So that's the minimal kind of things we want human to get involved. And then there's questions about, okay, when the AI are not perfect, when they haven't reached the level of intelligence we want them to be, what are the other things we want human to do? So there are two parts, I think, to this question. For the first part, what are the minimal kind of things we want human to be involved? I think there are several things that are very important. For example, the intent, the original intent from your human, what kind of task we want to accomplish. I think usually that's better to be originated from the human. Even though sometimes we can imagine a world where AI can also actively make suggestions without human to initiate the request, but still human needs to make a decision whether I really want that. So the call for in the initial request usually needs to start from human. And then after that, it's often not just once. It's often not providing a one initial intent and let AI do everything else, because there's natural ambiguity in when we express what we want. We often choose to say something short, but there can be a lot of disambiguation needed from AI agents, and so likely we also need to iterate a few times until that intent is very clear for the AI to execute. So that's the second thing I think human needs to be involved. And the third one is once the AI returns with certain results or actions, does if the result is not exactly what we need to be, or when there's a need for human verification, then human needs to look at the result and provide feedback. If anything is left to be further addressed, so that's feedback. And sometime and the fourth one I think is sometimes the human needs to override the decisions made by the AI agent and take over when it becomes to become necessary. So these are the, I think, four very basic elements that are likely need to be need to require a human to be involved, but depending on the quality of the AI techniques or agent capabilities, the degree can be more or less for each of them. For example, if the AI agent can always return with the best quality and a satisfactory result, then maybe the feedback part we can be less involved, and so on. Yeah. And this is like some basic analysis, and I feel like there are something else that's are interesting to think about beyond this. So for example, teaching. So if the AI, I mean that's before the AI can do everything we want. If we want them to handle some very specific tasks, if they lack the knowledge, lack of the skills, then some amount of teaching is required. And we can imagine building this teachable agents that can the human will teach them the necessary information or knowledge, and then they can iterate over time and become better. And after a while, they can use the lessons we give them to do the follow-up tasks. But initially, this interaction of from human is needed to do the necessary teaching. And
Yeah.
and also, you think about the opposite side of that, and that's the learning. So sometimes human, even though when the agents can do the tasks, humans still have a like interest to learn how they did them, both for curiosity, for sometimes it's for like ensuring the correctness. But sometimes some other times they want to gain the skills themselves. The human want to become better so they can vice versa learn useful skills from the AI agents. I think that's also a natural incentive for human to keep engaging with AI agents. And yeah, so these
Yeah.
are there are several things in my mind.
Yeah, when I think about this problem, I try to make a connection to the way I was thinking, basically mimicking kind of human what a human would do. And as I said, I think about large language models as a kind of a human with the medium level intelligence. And I think when we think about human in the loop, first where to get human in the loop, I think one probably useful way is to look for the gaps between probably medium level intelligence this model with actual human. So there
Right.
are several places we can there are clearly some places there are probably gaps. First is probably intelligence, like the most intelligent humans on Earth can be much more intelligent than those models, and those on those very challenging tasks we do need that extra intelligence, and probably just for confirmation, just for verification, but that level of intelligence is still needed. And probably some other levels that is unique to the human race is probably, for example, ethics, and for example, security. We do have these considerations, especially in high stake applications, and probably that those are the places we may want to consider getting human in the loop to ensure the solution developed based on those AI models are accurate and also ethical and also secure. So those are the I think places we should definitely consider.
Okay. So I appreciate all of those. I think they make sense. I want to change topics for a moment.
Yeah.
You've both recently forked the original AutoGen code and started AG2. I would love to hear about what led to that decision. And Xingwen, why don't you start and tell me why you decided to fork the code? Was there something that wasn't working for you within the environment that it was previously in? What did you want to do? And then where do you want to go with AG2?
Yeah, thank you, Matthew, for asking that. So yes, actually, as we kind of discussed, mentioned, this AutoGen project since the beginning is a collaborative effort between Microsoft and many other contributors, including myself at Penn State University, and actually there are other students from other universities. So at the beginning, we together decided that we are okay releasing the code under the Microsoft organization, and because it is still open source and MIT license, so we think that's fine. And
Mhm.
actually, it works well. It works fine for a while, like for over a year. And we have been, although we are not from Microsoft, me and my students and many other students and my collaborators, they are not from Microsoft, but they have been contributing, and we are working together well at the beginning. But as the project grows, um, there are like complexities. First of all, like in terms of like managing how to manage the project, right? Within Microsoft, there might be some people they want to try to take the project into a particular direction, and there is involvement
Right.
of leadership as well. And I think you understand that in big corporate, there are a lot of factors that affect how a project may go. And I'm not saying that I'm not complaining, saying it's bad, but it's a reality, and it actually slows down the project a lot, and a lot of times our progress is slowed down, and there are external contributors.
If I can interrupt for 1 second,
Yeah.
speaking of speed, I feel like every other day I'm seeing a new post on X about a set of new features for AG2. So whatever has changed between AutoGen and AG2, the reins are off. You guys are moving so fast. It's so impressive. Sorry to interrupt, Xingwen. Please continue.
Yeah. Thank you, Matthew, for pointing that out. Yeah, that's one of the primary consideration. We want to move fast. We want to have the autonomy to make decisions and to move forward together with the community instead of getting tracked by many other factors. So that's one important factor. And another factor is it's like making it kind of grow AutoGen in a more neutral place is kind of making it more convenient for the others to contribute. Like there are many contributors from other big companies who may not want to contribute to a project that is living under Microsoft. So that's another reason we want to make it much more convenient for the others from all organizations to contribute to the project. So those are the two main reasons. And thank you for mentioning that we are making much faster progress. And we are indeed very happy about that and very excited about it. And our community engagement has grown a lot as well. We have now contributors from Google, from Meta, and actually from Microsoft as well, and also from IBM, and also from other small companies and universities. So it's the community energy is super fascinating.
Okay, so you're building AG2 now. And by the way, for everybody watching, I'll drop all of the links to the GitHub, to the main website. I'll drop everything in the description below. What are your short-term and long-term plans? What are the things coming that people should be excited about?
Yeah, short-term plans. I guess I can disclose that probably that won't spoil like kind of the surprise. Okay, so we are, first of all, we want to keep it a community driven project. So we are constantly soliciting kind of feedback and advice from the community, and also more importantly from our users on what we should do next. So this is generally our principle right now. Like we want to use this use case driven development, and whatever needed from the use cases, and we'll try to add that. We'll try to support it. And right now we are extending. Like as she mentioned, we recently released our Captain Agent, Swarm Agent, and knowledge graph, graph rag, and structure output. So we have a lot of updates already. And in the short term, we are planning to expand AutoGen to AG2 to real time, to have better support on these real time use cases. For example, real time voice agents. So that's something that I feel very excited about in the short term.
One thing that seems obvious that's going to be coming in the future, but it really hasn't been here yet, is agents that are proactively accomplishing things on your behalf. Where the agent, I think agents in general right now, they do a lot, but you have to tell them like, hey, go do this thing, and they don't necessarily have easy access to your personal information or corporate information. You kind of have to set all of this up. When do you think we're going to be at a point where agents are more autonomous, more proactive on accomplishing things on your behalf 24 hours a day?
Yeah, that's a good question, and that's a very exciting question to think about because it saves so much time of a person. I think in terms of technology, we are very close, or already very close to reach that. It's just I think one tricky part is the kind of human interaction interface, the UI UX, because although we want the agent to autonomously finish task, but we still want to have the right authorization mechanism. Because, for example, I don't want the agent to send out an email that I don't like, right? It's
Right.
nice that it can
Right.
send an email, help on behalf of me, help me send out the emails, but if it's a very important email, I hope to review it first. So I think
Yes.
this human in the loop mechanism, as long as that is in place and that contract or protocol is established or is well designed, then we are very close. I think probably somewhere on the earth, someone already invited this fully autonomous system.
And
Yeah,
how
I
about
think
you, Shay? What do you think?
for special domains, like Jing said, I agree that the technology wise, there's no fundamental blocker. Because everything tasks that take a lot of time to run, and currently agents are able to keep running, and after they finish the work, they turn the result. The only kind of thing that's different from what you described is the user needs to provide the initial request. But that step is supposed to be automatable as well. Um, like we have for example, another agent just play the role of the user of sending that request, and once a while it simulate what the user will say, and then trigger the remaining of the agent team to do the work. And if there's no kind of constraint in the computer resource, or like if you don't need to worry about the bills, that is doable. But I think there are several kind of reasons we haven't seen that running in real. One is maybe aside from the cost concern, I think the one thing is the quality is not guaranteed. Because when users send a request, users clearly know this is a task they want to accomplish, and when the agent does it for the user, we don't know whether they always do what we want. Maybe for maybe it works well for a week, but the next day it does something unwanted, and it maybe cause some very undesirable consequence that we don't know who should take the responsibility for. And so that's kind of similar to maybe the self-driving car. I think the technology-wise, we have very good technology, maybe for a while, but for many regulation requirements, or like say how to separate, how to kind of clarify who takes responsibility. So many considerations like that prevent it getting used. But for if it's like let's say if it's one individual, and the individual takes all the responsibilities for themselves, they potentially already can do this. But then after the technical viability and the next question, or meeting all the regulatory requirements, I think there's still a question about whether we really want that to happen. So so in my kind of outlook for maybe the next 5 to 10 years, I think we should be able to get to a world where agents can finish most of the tasks from like say from the idea suggested by the human to nice result with minimal human supervision. But at that time, we still want to make sure that we can, if we want to delegate tasks to agents, we can. But if we want to do things ourselves or take over ourselves, we can. We also can. I think that's very important to guarantee that. I think before that guarantee can be made, there will be always this question: can we really let it go? And also, Yeah. So, but I think once we reach there, so if we think a little bit forward, once we reach there, and then maybe the question people will spend in thinking is for everything they want to achieve, do I do it myself or do I delegate? I think that will become a non-trivial question for human to think about it, because it's not necessary that I want everything to be done by my agents. I think that's an interesting kind of question to think about. That's maybe sometime later. Yeah, maybe in next maybe 5 years later or 10 years later.
Well, I'm really excited to see what the future of AG2 is. I've said it a million times. I'm kind of known for this saying bullish on agents. I'm waiting for the time in which agents can connect to my personal accounts and really accomplish tasks. And I think, Xingwen, you mentioned specifically, you don't want agents to just write an important email and send it, but to draft it and have it ready for me to then review and send, it would just save me an immense amount of time. So I'm very excited about that future. I want to thank you both very much for spending the time with me today, chatting with me. This has been fascinating. And I want to also thank you once again for contributing to open source and really starting the agentic framework wave. And there's a lot of exciting things coming. I'm going to drop all of the links in the description below. But once again, thank you very much for chatting with me today.
Yeah, thank you very much, Matthew, for having us.
Yeah, thank you very much. Thank you. It's great pleasure talking to you, and yeah, it's a very unique experience.